Now let's talk about the behavior of your solution, okay? When t goes to infinite, okay? We are interested about like the shape of your graph, okay? It could be plus infinite or minus infinite, or like your solution is converging to somewhere, okay? We can figure this out, okay? We already discussed about this one before, but let me try to explain this one more time, okay? Here we go. Like with example, it might much easier, okay? So I have second order linear differential equation with constant coefficient, okay? It is homogeneous as well. Then as we practice so far, and we're gonna start from the characteristic equation, okay? So here we go. The characteristic equation of the given differential equation is r squared minus 1 equal to 0, right? Because there is no y prime term, right? And then like we can easily find the factoring of this one, r minus 1 and r plus 1 equals 0. Then we found the root of this quadratic equation, which is 1 and negative 1. Is that okay so far? Okay. Then we can write the general solution, right? Here we go. Is yt is equal to the linear combination form of these specific solutions, right? C1 e to the RT plus C2 e to the RT, right? Okay. And then look at that. So do you remember whenever we want to talk about the like solution behavior when t equals to infinite, and we have to focus on your exponential function, okay? So you can easily figure this out when t is getting bigger and bigger and bigger, and this will be e to the minus infinity term, which is equal to 0, okay? Which means like that e to the minus negative power term will be dominated like when t goes to infinite, okay? But the first term, e to the positive coefficient of t term will goes to infinite, okay? So it depends on C1. If your C1, which is coefficient of e to the t is positive, then your solution goes up forever, okay? If your C1 is negative, then C1 is the t term will goes down forever, which is minus infinity, okay? This is the behavior of the solution when t goes to infinity, okay? So let me summarize this, okay? Here we go. As t goes to infinite, your solution will be just C1 times e to t only because e to the minus t goes to 0, right? And so in general, if the solution is yt, which is linear combination form of two specific equation solutions, C1R1t plus C2R2t, and we assume R1 is bigger than R2, right? So like they could be both positive, okay? But if your R1 is bigger than R2, then definitely your first term, which is C1 times it's the R1t, will be dominate your second term. Is it okay? That is the idea, okay? Here we go. Let me see this, okay? When t is increasing, and we assume like a C1 is not equal to 0, definitely, okay? Then C1 e to the R1t dominate the function, which means the solution is almost same as C1 e to the R1t. Is it okay? So like, this is the idea, okay? So let me try to go back to the like previous example, okay? So, okay, here we go. Which one? So let's start from the beginning, okay? I think it should better start from initial value problem. Look at this one, okay? This one, we used the characteristic equation and we found the solution form, right? Let me see. Look at that. It is like e to the minus 2t minus to the minus 3t, right? Then when t goes to goes to infinite, then as you can see, what happened? E to the minus infinite equals 0, and also e to the minus infinite 0. Okay, okay. So your solution yt goes to 0. Okay. So if you don't trust me, you can try to draw the graph of like a graph of this solutions curve. Then when t goes to infinite, your curve will converge to the x-axis. Okay. So what about next one? Look at this one. So both like powers are positive, but as I told you, like 3/2 is bigger than 1/2, right? So your second term will dominate your whole solution, right? So we can say when t goes to infinite, your yt will be almost here, okay? But like definitely like your t must be very, very big number, right? And do we have more? And I think that's it, right?